Hey, exercise number 4. Boolean with a cube and spheres. So it says like this: generate a cube of arbitrary dimensions, meaning whichever dimension you want. Generate spheres that use a variable radius. So just input a slider there, so you can vary the radius. So generate spheres that use a variable radius centered on each of the cube corners. So you will have 8 spheres. And extract from the cube the volume of the spheres. So let's do the cube first. We're using box again. You can find different types of box components or components that generate boxes. On surface and primitive, we can use center box again if you want. And we have a box, and this is an arbitrary dimension. If you want to modify this, just input a slider in the 3 input dimensions in here. So we have a box, and now we want to make a sphere for each of the corners. In order to generate spheres, again, surface, primitive, we have this one, sphere. We have actually more than one type of sphere generating components, but this is the one that we need, because this one uses a radius and a base plane, which basically is the center of the sphere. All right, so the radius needs to be variable, so just input a slider. I'm gonna write 0.33 as a radius, because I think this one has like the edge of 2 units. And I don't want this to be too large. And now, how do we input the corners of the box as centers for the sphere? Well, we need to extract those corners, and in order to do this, you're gonna go to Analysis, and we have deconstruct box, but we don't need this one because this one gives us some basically some parameters that we don't need. But we're going to use deconstruct brep. Brep meaning any surface or polysurface. Polysurface meaning a cube is basically made of 6 surfaces, the 6 sides. So we're going to use this one, this deconstruct brep, and this one gives us the faces, the edges, and the vertices, and I'm going to make this disappear. And the vertices we're going to use as base points for the spheres. Whoopie-doo. And what we need to do now is extract the volume of the spheres from the initial cube. In order to do this, we're going to go to intersect. Here to shape, we have some operations that are usually named Boolean operations. And we're going to use Boolean operations are these ones. Union, where you have 2 objects that you make as one. Intersection, which means that the the volume that how should I say? That is found in both objects is kept, but we need this one, solid difference. Solid means polysurfaces that are closed, so that are watertight, that have a fixed volume. If you have, never mind. Hopefully you get it. So solid difference, this one. We also have mesh difference, but this is for geometry that is defined as a mesh. But Rhino and Grasshopper usually work with NURBS geometry, and this is NURBS geometry. So if it doesn't say in the title mesh, it means that it's NURBS geometry, not mesh geometry. So solid difference, this one, bam. And so in A is the initial volume or shape, which is the box, and in B is the shapes that we want to extract from that initial shape or volume. And these are the spheres. And here, if we click on draw preview, only draw preview geometry, or draw selected. Basically this it means, it just draws the selected component. We get what we wanted. We can also just select all these, disable preview, and then deselect the previous selected only option. And we can modify the size of the sphere, and that is all.